Remember we talked about quadratic roots. If we have a quadratic equation, okay, so if we have a quadratic equation, ax squared plus bx plus c to be equal to 0. So we saw that the quadratic root, which is x, is actually equal to all over 2a. This is the formula method. Okay, so we said that the value under the square root is called the discriminant of the quadratic equation. So this is your b squared minus 4ac. We have our d satisfy 3 conditions that will tell you the different kinds of roots that that equation is going to have. So for an equation where the d is positive, that's greater than 0, we said that you are going to have real and distinct roots. Okay, so your roots are going to be real and distinct. Distinct, like I said, means different. Real means it's going to be real numbers. And if your d is equal to 0, we said that you are going to have real numbers, but that they are going to be the same. So real and equal roots. Okay, so you can attach that here. And then finally we said that if the d is less than 0, that's negative, then you are going to have complex roots. Okay, so it's important that we take note of this. Okay, now from here, now I said that there are some examples that we can start seeing from these particular concepts that we have seen here. Now look at this example here. Okay, so here you're given a particular quadratic equation, and instead of giving you the value of your b, which is the coefficient of x, they brought in a variable k. And then also, instead of giving you the constant c, they also represented it with k squared minus 2k minus 1. And so they are now asking you, for what value of k will this particular equation have equal roots? So what are they expecting you to do here? To make use of this information that you are given here. And what is the information? That for a quadratic equation to have equal real roots, we did not put that. Please attach that here. For a quadratic equation to have equal real roots, something must be done. And what is that? The discriminant must be equal to 0. And so what is your discriminant? So let's begin this solution. Okay, permit me to remove here. I believe that you already have it. Okay, so now for the roots to be equal and real, then the discriminant must be 0. So our discriminant d must be equal to 0. So the question now is, what is our d? It's already given here. So we need the value of b. And what is our b? Our b is minus 2x plus 1. And what is our a? We are given b squared minus 4ac. So what is our a? Our a is the coefficient of x squared, and the coefficient of x squared here is 1. And then c is a constant, which is the whole of this. Okay, and that is k squared minus 2k minus 1. Okay, so let's now begin to substitute into our formula. So if we substitute here, what we mean is that b squared minus 4ac must be equal to 0. So if we substitute our b as minus 2k, see me now, sorry about that. This thing here is 2k, not 2x, please. And then all squared, which is our b squared, minus 4 times a, which is 1, times c. Our c now, in fact, we may decide not to write this one, since anything multiplied by 1 is still that thing. So let's not waste our time writing that one. So we just have k squared minus 2k minus 1. Alright, so you are now saying that all of these must be equal to 0. That's the condition for equal real roots. Okay, so that's now going to be, so all you need to do now is to simplify what you have here and then find the value of k. So let's quickly do that. So for the first line here, what are we going to have? You know that if you have minus 2 squared is the same thing as 2 squared. So it's the same thing as removing this minus sign. So in other words, we are just going to have 2k plus 1 times 2k plus 1. Alright? That's the meaning of square. And that is minus, so minus 4 will now enter here. Minus 4 times this will give us minus 4k. So if we open this bracket for the first one, 2k times 2k will give us 4k squared. So bring down what you have here. You have minus 4k squared equal to 0. So what's that now going to be? So we try to simplify what we have. 4k squared will cancel minus 4k squared. Then k will collect themselves. 2k plus 2k is 4k plus 8k is 12k. It's not 12,000. No. It's just normal k. And so don't mind me. So 1 plus 4 will now be 5. And everything is equal to 0. So you now have 12k is equal to 5 coming over here will be minus 5. Therefore, our k is equal to minus 5 over 12 as your solution. So you discover that this particular thing that looks like it is big is just giving you the solution as minus 5 all over 12. So these are some of the applications of the things that we learned. That's the types of roots that you have and what produces them. So depending on what you're asked, you should know what to do. Assuming we are told to find the value of k so that the root will be real and distinct, that means we are going to use b squared minus 4ac should be greater than 0 to solve, and then you just substitute. So look at this other question. It says the roots of a quadratic equation of the form ax squared plus bx plus c equal, a quadratic function of this form, are real and distinct if graphically plotted. The curve cuts the x-axis at. This is, I'm reading from one of our past questions. This is Maths 101 exam of about last 2 sessions. So it's just to let you know that what we are doing here is what things that you should expect. So now I'll read it again. That a function is given like this and it's a quadratic function. So if the roots are real and distinct, when graphically plotted, how will the curve cut the x-axis? I'm trying to explain the question now. And I remember I said this yesterday. Option A says it will cut the x-axis at 1 point. B says at 2 points. C says at no point. D says at all points. And E says nota. Remember, I've always explained to you nota. Nota means none of the above. So A says 1 point. It will cut the x-axis at 1 point. B says it will cut the x-axis at 2 points. C says it will cut the x-axis at no point. That's 0. And then D at all points. That's the D does it make sense? Doesn't really make any sense. So as what I told you yesterday, if it is real and distinct, it will cut the x-axis at 2 points. If it is real and equal, it will cut the x-axis at 1 point. And if it is complex, it will cut the x-axis at no point. So this is equal roots. This is distinct roots. and this is complex roots. Okay, this one is nothing at all. So it's important that you take note of all of this. Like I told you yesterday, all of these are exam questions for us, and so you should be able to handle questions like this. All right, quickly let's move on to the symmetric properties of roots. Inside there, I'm also going to bring up other examples that are even from our question here. Okay, so symmetric properties of roots. So when we begin to talk about symmetric properties, what are we saying? Or we can just say symmetric roots. Okay, so we are only saying that the roots of quadratic equations have some relationship that you can form on them, and that will help you do a whole lot of things. Okay, and what is that relationship? Okay, so now if I have, for instance, let the roots of an equation be represented as alpha. Let the roots be alpha and beta, so that you see where this alpha and beta is coming from. So your alpha is invariably representing one x, while beta is representing another x. Okay, so if alpha and beta are the roots of an equation, then from here we began to develop some relationships. And what are those relationships? Number one, we saw that if you add the two roots, that is going, remember that this is the equation that it is a root. That's the general equation, ax squared plus bx plus c equal to 0. So we saw that if you sum the two roots, you are going to get the minus of your b all over your a. You can call this equation 1. And I'm going to show you how all of these were gotten. And then the second one is that if you multiply the two roots, is going to be equal to your c, which is a constant, all over the a. Okay, so these are the two first most important relationship that we saw between the roots of a given quadratic equation. Okay, so what do we now do with all of this? So these two now began to give us other roots, or sorry, other relationships. But before we begin to see those other relationships, let me try to show you where this relationship is coming from. You know that the next thing we are supposed to do is formation of quadratic equations. How do you form quadratic equation? Very simple, especially when you're given the roots. So for instance, let me say that I am given x to be equal to 2, and that's x1, and the second x is equal to 3. How do you form the quadratic equation that produces this? So usually we'll say transfer this to the other side. So you have x minus 2 is equal to 0, or x minus 3 is equal to 0. So you are going backward. During factorization, you will go up and split and get this answer. Then now we are going backwards to get back the equation that produced this. So, and what's the next thing? So since this is 0 or this is 0, that means their product is going to be 0. So we join them. And so when we join them is equal to 0. And if you open this bracket, you will get x squared minus 3x. That's x multiplying this. And then minus 2 multiplying will give you minus 2x. Minus 2 times minus 3 will give you plus 6 is equal to 0. And so from here, you will obtain that the equation is x squared minus 5x plus 6 is equal to 0. Of course, if you solve this equation, you will get back your x equal to 2 and 3. Okay, so this is the process of generating the quadratic equation when you are given the roots. And that's exactly what I want to do with this alpha and beta now. I want to remove this. We'll still do some examples on this, on generating a quadratic equation, but I'm just showing it now for the purpose of what I want you to see, how we got these two formulas. Okay, so assume now that my first x is alpha, and then the second x is beta. So what does it mean? if I do like I did with 2 and 3, so I'm going to have x minus alpha is equal to 0, or x minus beta is equal to 0. Okay, and that is going to give us, so if we join these two now, we will have x minus alpha multiplied by x minus beta. Okay, x minus beta, everything is equal to 0. And so from here, if we now open this bracket, we are going to have x times x will give us x squared, x times minus beta will give us minus beta x, minus alpha times x will give us minus alpha x, minus alpha times minus beta will give us plus alpha beta, and that is equal to 0. So if we now try to join these together, we are now going to have x squared. I want to factorize. Let me bring minus out. If I bring minus out, I'm going to have beta x plus alpha x. Okay, then plus alpha beta equal to 0. Now I want to bring x to this other side, so I'm going to have x squared minus beta plus alpha. If the x comes to this side, it will be, I'm just factorizing. If you open this bracket, you will get back this, and that is plus alpha beta equal to 0. Okay, so, and then of course you can see now that I can also, this is in their language, alpha means a, so we can write our alpha first. So this is going to be alpha plus beta x plus alpha beta equal to 0. Okay, so now this is exactly what you will get if your roots were alpha and beta. And so if you compare this equation with what we have originally, which is ax squared plus bx plus c equal to 0. Now look at this one. The coefficient of x1 here is 1. So let's divide through by a. If we divide through by a here, you are going to have all of this. So this will give us, a will go away. So we have only x squared plus bx over a, then plus c over a is equal to, we will have 0 here. Now watch what that is going to give us. So if you compare this and this equation and this, so you have x squared minus alpha plus beta into x plus alpha beta equal to 0. You discover something. Your x squared will match to x squared, and then that means the coefficient of this must be equal to the coefficient of this, and your constant must be equal to this. So this is how we got that minus alpha plus beta is equal to b over a, and we got that alpha beta is equal to c over a, and that's exactly what we have here. So here, if you take this minus to this side, you will get that alpha plus beta is equal to minus b over a, which is exactly what we got from the equation 1 here. Okay, so that is just to show you how we got these two relationships excuse me, that led us to the all other symmetric properties of quadratic roots. But before we, let's see other forms of a relationship. I've shown you the first one and the second one. Now the third one is the one that occurred between the square of alpha and the square of beta. This is equal to the alpha plus beta all squared minus 2 alpha beta. And of course, you can also see how this was gotten. Usually when I teach my students, I show them how things were obtained. so that you don't go about cramming formulas and all that. You should be able to say, okay, I'm following or I am not following by knowing how things were gotten. Please, if you have any question, you can drop it on my WhatsApp. You can use either a picture. I forgot to tell you that if there is any question you have in this topic, you can send it to me. If you indicate in the group here, in the chat, this thing on YouTube, that you have a question, then you can send the question to me to my WhatsApp number. You should be able to see it anywhere, or ask somebody to tell you. Okay, so I can respond to your question as one of the examples on our lesson today. Okay, so let's go on. So, and now whenever you are giving alpha squared plus beta squared, the mistake that people make, which is what we taught you in indices, is to think that this is going to be equal to this one alone. No, it is not equal to alpha beta all squared. No, this is not true. Okay, so you can see the difference here now. All right, so it's important that you take note of that. Now the question is, how was that gotten? You can also be able to get or know how the process of getting all of this. And what I usually would tell students is very simple. If you want to get alpha squared plus beta squared, expand this one. Let me go to the next one. If you want to get alpha cubed plus beta cubed, expand alpha plus beta all cubed. When you expand this, then you will get this and make it the subject. Let's quickly do it with the square own, and then we move on. So I want to get alpha squared plus beta squared, as in how did we obtain this formula? I want to get it now. So all I need to do is to expand the sum, the square of the sum. If you expand this square, you're going to have alpha plus beta times alpha plus beta. And what is that going to do for us? Alpha times alpha will give you alpha squared. Alpha times beta will give you alpha beta. Then beta times alpha will also give you alpha beta. Alpha beta. And then beta times beta will give you beta squared. Alright, so see what we'll have now. We'll have that alpha squared, you can bring this one close to it since that is what you're looking for, plus beta squared. Now this one plus this one will give you 2 alpha beta. Now remember that this is what produced that. So but this is what we are looking for. So if we make it the subject of the formula, so we will have alpha plus beta all squared. This one crossing over here will now give you minus 2 alpha beta, to be equal to alpha squared plus beta squared, which is what you were originally looking for. So that's how to obtain all of these symmetric properties. Most times, of course, in exams, we don't necessarily go beyond square. At most, we can come to cube. But if I were you as a smart student, you can go beyond cube. You can even do raised to power 4. Okay, so for instance, this one is equal to alpha plus beta all cubed minus 3 alpha beta into alpha plus beta. And then somebody will be thinking now, how is Mr. Precious able to remember all of this? I have always told you in class that the principle of learning is embedded in the principle of repetition. I can remember this because I have used them over and over and over again. It's not because I'm a lecturer. Please take note. Some of you always make yourselves feel inferior. You say, Sir is doing this because he's a lecturer. It's not true. I am not doing it because I'm a lecturer. I'm not doing it because I'm a teacher. I'm doing it because I have done this over and over again and I've gotten used to them. And the implication is that if you do the same, you will also produce the same result. Now, the question is, what do we do with this? Where is the examples that will involve this? For some of you who have done your workbook exercises, you would have seen a lot of questions that came from this. But I'm going to read this one example from this same past question. It's number 19 here. It says, Okay, so we are doing example now. Let me call it example 1 for this particular subtopic. It says form the quadratic equation for which the sum of the roots is 6. Okay, we want to get the quadratic equation whose sum of roots is equal to 6. Now remember we said that we use root alpha and beta to represent roots. So whenever you see me write alpha plus beta, it means I am summing the roots. Okay, so now it says that you are forming a quadratic equation whose sum of the roots is 6 and the sum of the squares of the roots is 56. So sum of the squares of the roots. So if we square the roots and sum them, is going to give 56. So they are asking us to get the equation that will generate this effect. And it's easy to see. So first of all, let's get back to what I showed you here. Okay, we actually use this formula to form equations or quadratic equations when the roots are given. That's if you do not want to follow the process I followed here when I wrote x equal to 2 or x equal to 3 and then I transported to the left hand side, open bracket, all those things. If you don't want to stress yourself doing all of that, you can just use the formula. For instance, let's go down here. For instance, that time I said that our x is equal to 2 or x is equal to 3. You can just use the first x as your alpha and the second x as your beta. What that means is that you can use that formula x squared minus alpha plus beta into x plus alpha beta equal to 0. If you use it, it will give you that same answer we got that time. And what is it? So I'm going to have my alpha plus beta, which is 2 plus 3, will give me 5x plus alpha times beta 2 times 3 is 6 equal to 0. So the beauty of this is that it goes straight to give you the solution. Now let's go on to try to answer this question. So invariably, for us to be able to form this equation, what we need now, we have already gotten alpha plus beta. So if we put it here, that means we have gotten x squared minus 6x. So we now need to get your alpha beta to complete for the equation that this question is looking for. So quickly, let's try to get that solution. Okay, so in other words, we need to get alpha beta. And so to get alpha beta is very simple. You have given me the value for alpha squared plus beta squared. And I know that there is a relationship between alpha squared plus beta squared and alpha plus beta, which we said is alpha plus beta all squared minus 2 alpha beta. Now, I have told you that what you need now is to get alpha beta. And once you get your alpha beta, substitute into this formula since you already have alpha plus beta and your equation will emerge. So how can we do that? You've already told me in the question that alpha squared plus beta squared is 56. And that is equal to my alpha plus beta. You also said that it is 6. So I will square it minus 2 alpha beta. And so from here I can easily now make alpha beta the subject. Alright, so this is going to give me 56 equal to 6 squared is 36 minus 2 alpha beta. And so if I carry my alpha 2 alpha beta to this side and this one to this side, why am I carrying 2 alpha beta? Because it's negative here and I want it to be positive. Okay, so and that's equal to 36. This one coming over here will become minus 56. Okay, and so that is going to give me 2 alpha beta is equal to this minus this is minus 20. And so my alpha beta is going to be minus 20 over 2, which is minus 10. And you are done. So what is the equation we are looking for? That is x squared minus alpha beta is 6. So you have 6x plus, in this case, your alpha beta is negative 10. So that minus will cancel this plus. So you just have minus 10 is equal to 0. And that is the solution. And of course, if you go to the options, that is option D. Okay, so it's very important, critical. This has taken us this long because I am teaching you now. By the time you start doing this yourselves, you will discover that it is very easy to handle questions on this. Okay, so quickly, let's go down to some exercises and see what we can do. Okay, so examples. Okay, so we are asked to find the sums and the products of the roots of this equation. And funny enough, what majority of us will want to do is to try to solve these equations, and then we get the two roots and then we will sum them. If you try that, you will be in that exam hall and that exam will finish on top of your head. So please, it's important that you are able to know what to do, what is required of you. So what is required of us here is to use the principle I just taught you now, that the sum of roots is equal to minus b over a, and that the product of roots is equal to c all over a. So all you need to do is get the a, b, c of each of the equations, and that will give you what you want. Okay, so let's go to the first one. The first one is very straightforward. The sum of the roots, which is alpha plus beta, is equal to minus b, which is our b is minus 2 all over 3, and that is going to give us 2 over 3. So the sum of the roots of this equation will be 2 over 3, while the product of the roots is going to give us minus 7, which is c all over a, which is 3. And that's your solution. You are done, no? Nothing more. Let's go to the b part. Okay, I will leave the b as an exercise for you. Kindly do that. So what are you expected to do? The question self to ask is this a quadratic equation? And it's left for us to find out. And how do you do that? Very simple. Remove this fraction that is here. Once you clear this fraction, you will discover that it is a quadratic equation. And there are two ways you can clear the fraction. One is to get the LCM. So I can make this over 1 and find LCM. And then the second way, which is the way I prefer, is to cancel this root, the denominator, by multiplying through by this particular denominator. So if I multiply through by p, I will remove this p. So if I multiply here by p, I will get p squared. If I multiply here by p, p will cancel p, so I'll have only 1. If I multiply here by p, I will get 2p. So those of you that would love to take LCM, you still get the same thing. So if you now bring this 2p to this side, you will get p squared minus 2p plus 1 equal to 0. Now, meanwhile, I'm happy to hear or to notice that most of you are following. That's very nice. All right, so that it won't be that I'm just talking to myself. So immediately the quadratic equation appears. You are done. You are done. What's the sum? So in other words, this person only wants to test if you know how to generate this quadratic equation from this. Okay, so the sum now is equal to minus 2 will give us 2 over 1. So your answer is 2, while the product will be 1 over 1, which is equal to 1. So you see that it is even simpler than the one you did. The one you people did gave you fractions. This one even gave whole numbers. All right? And so we move to example D. Should I allow you to do that one? Okay, so for example D, it will be good that we do that using LCM approach. Okay, so this is so that you will know. Jax, you're welcome. Your answer is correct. So this is so that you will know which one to use at any point in time. So if I take the LCM of this, that's going to be, we can make use of 2y. Just multiply the two of them so you don't waste your time. 2y times y plus 1. Okay, so if we take that as our LCM, 2y divide this, you get the same y plus 1 here. Then bring down your addition sign. y plus 1 divide this, you get only 2y, and okay, that is going to be equal to the right hand side, which is 1 over 3. Okay, so let's go. So now you can now open the bracket if you want. Okay, so now we can cross multiply, but before cross multiplying we can sum the numerator here. So y plus 2y will give us 3y, so we'll have 3y plus 1. So let me remove this. So we have 3y plus 1 up there. Okay, so let's cross multiply. So let's open our brackets now. So we'll have 2y squared. Okay, so and we are done. So collect like terms. So we have 2y. In fact, move everything to this side. This 9 coming here will become minus 9. And 2 minus 9 will give us minus 7y. And then 3 coming here will be minus 3 is equal to 0. So this is all this person wants to know. Do you know how to generate your quadratic equation from this fraction that looks like this? That's all. Once you are able to do it, you will discover that the main question the person is asking you is very simple. So now, what is the sum of the roots? Your alpha plus beta is going to be equal to minus 7 will give us 7 all over a, which is 2, and you are done. And what is the product of the roots? The product of the root alpha beta will be your minus 3 all over 2, and that is the solution. So nothing serious when you come to all of this. Okay, so we will take one more example on symmetric properties of roots. So it says if the roots of the equation here is given as alpha and beta, so we are asked to find the value of 1 all over alpha plus 1 all over beta. How are you expected to handle this kind of question? Now you are still going to make use of the concept of symmetric properties. All these things that we saw under symmetric properties of roots, that's what is going to help you here. All these where are they? Yes, all these formulas here that we formed here, that's what you're going to be using. So you must get used to all of them. Okay, so always remember that alpha plus beta is minus b over a, alpha beta is c over a, and alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. You know, remember, like I said, you are not cramming it. The constant usage of them will get you used to all of them. Okay, so let's go on now. So for us to get 1 over alpha plus 1 over beta, what are we going to do? Very simple. Now whenever you have fractions in maths, it's always good, Chuku, you are welcome, it's always good to try to take LCM and find out what it is going to give you. Remember, now you want to put in alpha plus beta. You are just, your eye is opening, looking for where you will see alpha plus beta and alpha beta. Now, because meanwhile, let's quickly do that self. In fact, whenever you are given this kind of question, the first thing you need to do is to get your alpha plus beta and your alpha beta. For this question, what is going to be our alpha plus beta? That's minus 3 all over our a, which is 5. And so our alpha plus beta will be 3 over 5. So we keep it somewhere. Then we also try to get our alpha beta. Our alpha beta is c over a, and that's going to give us 4 all over 5. So we keep these two somewhere because we are going to need them. So like I said, our job now is to begin to look for where we will see alpha plus beta and alpha beta. So inside this one. And so for us to do that, we will try to see if we can take LCM. And if we take LCM of this, that is alpha beta. And then we try to simplify. Alpha divide alpha beta, you will get beta. Then plus beta divide alpha beta, you will get alpha. And alpha times 1 will be alpha. And of course, you can write this as alpha plus beta all over alpha beta. because this is addition, so you can turn it the other way and it will still be the same thing. And then you are done. What is your alpha plus beta? You already have it here, so you just substitute. My alpha plus beta is 3 over 5 all over my alpha beta is 4 over 5. And so I can put this as 3 over 5 divided. You know, division, you can change it to multiplication, and this one will now become 5 over 4. And so 5 will cancel 5, and your answer will be 3 all over 4. You see how beautiful that is? So it just gives you your solution. That's the beauty of these symmetric properties of roots. So as I'm using it, my eye will be open to how will I get alpha plus beta and how will I get alpha beta, because those are the things you can get from an equation, except the other ones are given to you. But the ones you can find from an equation are these two. Okay, so let's go on. Example B. So B says we should find the value of alpha plus 1 into beta plus 1. Should I allow you try this one? Yes, I want to allow you do this one. And what I'm going to give you a hint. Open the bracket, and that will help you get the solution. Let me give you 1 minute, 60 seconds to try this. I'm waiting for you, and then I have from Ebuka. Ebuka, how did you sum your own? Alright, so let's do it together. Ebuka, I am sure that you are very much okay with what you did, but probably you did not sum well. You should have also gotten 12 over 5, because I think 12 over 5 is correct. Okay, so let's go ahead. So now if you open this bracket, alpha times beta will give you alpha beta. Then alpha times 1 will give you alpha. We are done with this, so we come over here. 1 times beta will give us beta, and then 1 times 1 will give us 1. And we are done. So what's that, Mary? I see your response. That's okay. So what is now our alpha beta? Alpha beta is here, 4 over 5. And then plus, what we have alpha plus beta, which is given here, 3 over 5 also. And then Jax, I can see your response. And then you add your 1. 1 is the same thing as 1 over 1. Take LCM as 5. This will give you 4 plus 3 plus 1 into 5 is 5 times 1 is 5. So if you add all of that, you get 12 over 5. I think 12 over 5 is correct. Okay, so that's it for that one. So let's go to example C. Am I correct? I think I should be. Okay, yes, I am. Okay, so what do we do here? Remember, like I said earlier, that you must always be careful with what you are looking for and what will help you get it. The only thing we have the value in all of this is alpha plus beta and alpha beta. So these two things are all we need. So in every of the example, we'll be looking for a way to get them. So how can we do in this one? You can clearly see that there is alpha here, there is alpha here. There is beta here, there is beta here. So at least I can bring out alpha beta and then factorize. Okay, so thank you. So here we'll now have, if I factorize here, what am I going to have left? I will have only alpha squared. Beautiful. And that is plus. If I factorize alpha beta from here, alpha will go, and I'll have only beta squared left. You see, math is nice. Once you understand the principle, stick to the rules, you won't have any issues at all. I'm going to remove this. Okay, so let's go. So what's going to happen now? So we already have the value of alpha beta, but we need to break down this. But we already also have the value of this. Like I said, I already know, and because I know, I'm just going to write it. But for you, you will keep practicing it. Okay, so what did we say is alpha squared plus beta squared? Because you still have to break it down to contain these two. This thing must enter into your head. So if you do that breakdown, you are going to get alpha plus beta all squared minus 2 alpha beta. That's what we said up there. Okay, and so you are done. Now everything we have here is in terms of alpha, beta, and